In this video, I'll go through question 17 from the 2012 exam. Note that this question's worth 3 marks, so the intent is to be able to work through it quickly. What we're asked to do is determine if any of the listed strategies is a Nash equilibrium point for the payoff table given in the question. The key is simply to remember what a Nash equilibrium point is. A pair of moves makes a Nash equilibrium point if no player can change their move to put themselves in a better position. So you go through each situation one by one and simply check if it's a Nash equilibrium point. For the purposes of explanation, I'm going to duplicate the payoff table and do a lot of writing. When you get to the actual exam, you don't have to show this much working. In this question, you'll get full marks just for writing down the answer. Part A is that players 1 and 2 both make move 1. That's this position here. If player 2 changes their move, it changes the state to this one here. If player 1 changes their move, it takes us down to this position here. Note that if player 1 changes their move, their payoff has gone from 1 to 3. And if player 2 changes their move, their payoff has gone from 1 to 5. If either player changes their move, they've put themselves into a better position. And that means this is not a Nash equilibrium point. For part B, player 1 makes move 1, and player 2 makes move 2. That's this position here. Player 1 has a payoff of 4, and player 2 has a payoff of 5. If player 2 changes their move, that takes them across to here. Player 2 has made their move worse. If player 1 changes their move, that takes the move here. And player 1's payoff has gone from 4 to 5. So player 1 can improve their position. Since player 1 can improve their position, this is not a Nash equilibrium point. Part C is that player 1 makes move 2 and player 2 makes move 1. That's this position here. Player 1 has a payoff of 3, and if they change their move, it brings them up to here, where they get a payoff of 1, which is worse. Player 2 has a payoff of 4, and if they change their move, it brings it across to here, where they get a payoff of 3. That's also a worse position. No matter what, if only one player changes their move, that player has been put into a worse position. That means that this is a Nash equilibrium point. It's possible to have more than one, so we should still check part D. Part D is that players 1 and 2 both make move 2, which puts us in this position here, where player 1 has a payoff of 5 and player 2 has a payoff of 3. If player 2 changes their position, it takes us from here to here. Player 2 has increased their payoff from 3 to 4, and so there's no possible way for this to be a Nash equilibrium point. So we cross that off, and now we can conclude that the only Nash equilibrium point is C.